Hey class, it's Miss Twang. We're going to complete activity 6.3.3, applications of the elimination method. Now remember, we've been talking about elimination method where one of the two variables in our linear equations is going to cancel out, so we can solve for both of them. First, we're going to write a system of linear equations and solve using the elimination method. Of course, some of you might be more familiar with linear combination method. This is where elimination method has to go one extra step so that something will cancel out. Sometimes it's rewriting the equation, sometimes it's a matter of multiplying one or both of the equations by a value. So you're planning a picnic for Memorial Day, which is coming up soon. It is the month of May. You need to buy enough hot dogs and hamburgers so your 10 guests can have at least one serving of each, right? So you determine that hot dogs cost 40 cents each and hamburgers cost 80 cents each, but you have $12 to spend on the hamburgers and hot dogs. How many hot dogs and how many hamburgers should you buy? We'll let hot dogs be represented by the variable x and hamburgers be represented by the variable y. So let x equal y, because remember, we want everybody to have at least one serving of each. So just in case, we want to make sure that we don't have way more hot dogs than hamburgers. It's alright if there's leftovers, because we can always have leftovers. Alright, the next equation, we're going to make sure to put the prices. Now, you could put 40x instead of 0.4x if you want to use whole numbers instead of decimals, but if you do so, make sure to make $12 instead of 12.0, make it 1200 if you're talking about terms of pennies and cents without any decimals. But I'm going to use the decimals since the question is written with the decimals. Now typically I would say go with the substitution method just because it seems like x was isolated when I have the equation x equals y. So typically that's what I would go with. Just looking at the two equations, if one of the variables isolated, I would think substitution would be the most efficient method. But since this is an application of elimination method, we're going to practice using the elimination method. So in order to use elimination method, we have to make sure the equations look similar. And right now, one equation has x and y on opposite sides of the equal sign, and the second equation has x and y on the same side of the equal sign. So I'm going to rewrite the first equation so that x and y are on the same side. Since I move the y from the right side to the left side, remember, think of an equation has to be balanced. If I'm thinking of war, it's enemies versus allies. If you change sides, you become an enemy or an ally, depending on whether you started out positive or negative. And in this case, y was positive on the right-hand side of the equation, so when it moves to the left to join the x, it becomes a negative y. Now you can insert the 1 as your coefficient for x and make the y a negative 1y if you wish. So what's left behind is a 0. And in order to get something to eliminate, I've decided to use x as my value, my variable to eliminate. So I'm multiplying everything using the distributive property by negative 0.40. Okay? So the equation rewrites as negative 0.40x plus 0.40y equals to 0. And you might be wondering why there's a plus sign in front of the y variable, but if you remember, a negative times a negative becomes a positive. Make sure you don't make that oops. I know we tend to rush sometimes and we forget our product rules. So negative 0.4x and positive 0.4x in blue cancel out. They get eliminated. When I combine 0.4y with the 0.8y, it becomes $1.20y or 1.20y. 0 and 12 make 12. Divide both sides by the same value. Remember, it's going to be the 1.2 I divide by because that's the value in front of x. So y equals 10. Looking back at the word problem, y represented the hamburgers, so there'll be 10 hamburgers. And since we set x equal to y to make sure we had equal parts of each, x will also be 10 as well. So that means there'll be 10 hot dogs and 10 hamburgers, which really works out since we only have $12 to spend. Not bad for 5 minutes of work. On to the next question. Okay, question number 2. Your family is planning to take the train from Hartford to New York City for a day trip. You learn that your friend Jackie took the train with a group of 3 adults and 5 children, and it cost them $269.50. That isn't chump change, for sure, but it is a lot cheaper than some of those parking garages. A cousin also took the train to the city with a group of 2 adults and 3 children, and it cost them $171.50. So your objective is to find the price of the adult ticket and the price of the child's ticket. In this equation, I'm going to let X represent the adults and Y represent the children. Of course, you can choose to use any 2 variables you'd like. I typically stay away from the variable O just because O and 0 often get confused. So I'm setting up my first equation to go with Jackie's family. 3 adults, so 3x, plus 5 children, 5y, equals $269.5 or $269.50. The cousin had 2 adults, so 2x, and 3 children, so 3y, and their total was $171.50. So notice 3x and 2x do not cancel each other out. They don't get eliminated because they're not opposites. Neither is 5y nor 3y. So in order to do so, I have to choose between, do I want to eliminate x or do I want to eliminate y? I typically go with whichever one has the smaller numbers because I want something to cancel out, and especially when you're working with larger numbers such as 269 or 171, it just makes it a little simpler math. This and the fact that I want to be able to solve for one so that I can solve for the other. So I've decided to choose x. Well, 3x and 2x, I'm looking for the least common multiple between 3 and 2. It just so happens to be 6. So I'm going to start by multiplying the top equation by 2 and the bottom equation by -3. You might be wondering why I chose -3, but remember, we need something to eliminate, so one of them will have to be positive, the other will have to be negative. So when I distribute the 2 to the top equation, it gets rewritten as 6x plus 10y. Notice the bottom equation is -6x. Oops, did you catch my mistake? Just like you guys, I'm thinking 3 and 3 is 6. But remember, it's -3 times positive 3y to make -9y. And that's going to really work out well because 6x and -6x will be eliminated. When I multiply 269.50 by 2, I get 539. And when I multiply 171.50 by -3, I get -514.5. So the x's cancel out. 10y plus -9y leaves us with 1y. Or you could just write it as y, because we know that there's an invisible 1 in front of the y. When I'm subtracting, make sure to subtract correctly. Decimals must line up. And you get 24.5, which is actually $24.50. Now you have to look back into the word problem. What did we assign for y? You're right, for the child's ticket. So y represents the cost per child's ticket, which is $24.50. I'm going to use that value and choose one of the original equations to substitute back into. You can choose either original equation. It doesn't matter as long as you follow the order of operations and the steps for solving an equation. I'm going to go with the top equation just because. So 3x plus 5, and instead of y, remember, I'll substitute the 24.50. Okay? So I substitute the 24.50 and I ask myself, can I distribute? Well, I've got my parentheses, so I'm going to distribute the 5. 5 will get multiplied by 24.50. I can drop down anything else that isn't being distributed or multiplied. So 3x can drop down, and so can the 269.50. When I distribute the 5, I get $122.50. Now the next question is, can I combine like terms? And the answer is, nah. I can't combine like terms because 3 has an x and 122.50 does not. but I can add or subtract something. Since 122.50 is being added, the opposite or inverse operation is to subtract. Whatever I do to the left side of the equation, I must do to the right side of the equation. So I'm going to subtract it from the right side as well. Again, anything that isn't canceled out or being subtracted simply drops down. So I'm left with 3x equals 147. Divide both sides by 3 since 3 was being multiplied to x, and I get $49. $49 is the cost for each adult ticket. And now if I go to purchase my ticket from Hartford to New York City, I know how much it's going to cost. Okay. Next question is about the basketball season. Of course, UConn women, had an incredible undefeated season, 39-0, and won the NCAA championship. Top scorers Maya Moore and Renee Montgomery combined for 1,398 points that season. If Maya scored 110 more points than Renee, how many points did each player score during the season? Of course, you could look up the stats, but that's not what we're here to do. Our goal is to try to solve the equation and figure out how many points each player had using the elimination method. I'm going to assign Maya Moore with the variable x, and I'm going to use y for Montgomery. So notice more points refers to addition, adding, and how many more? It's 110 more. So because they were combined, we also have to think about what operation goes with combined. Combined for 1398 or 1,398 points is adding. So x plus y equals 1,398. The second equation is going to be just x equals. Since Maya scored is going to refer to the equal sign, more than. So we're going to add 110 more than y. And normally, I would probably use substitution and plug y plus 110 in place of x, since x is isolated again in the second equation. But since we're using elimination method, I'm going to keep the top equation the same and alter the bottom equation so that x and y are on the same side of the equal sign. So notice I have to cancel out y from the right side and move it to the left by subtracting it. So the second equation will be rewritten as x minus y equals 110. Notice the 110 remains positive because it didn't change sides. Just like our enemies didn't become our frenemies. Or did I get that one wrong? Alright, x and x will combine to make 2x. Notice I use the green highlighter to cross off the positive y and the negative y because they get eliminated since they're opposites. When I add both lines, don't forget, it's a 1x plus a 1x to make the 2x. And then 1398 and 110 makes 1508. To get rid of the 2, how do I undo multiplication? That's right, I divide. So both sides get divided by 2. X will equal 754 points. That's how many points that Maya Moore scored. That's right. That's a lot of points. Even if she was only shooting 2s, even if she was shooting 3s, that's still a lot of baskets made. Now we have to go back and find out how many Renee Montgomery scored. Now we know it's less than that because Maya had 110 points more. But I'll use that first equation, or I can use that second equation. Well, I'm just going to use the second equation because I used the first equation earlier in a similar problem above. So let's use the second equation. Alright, replacing x with 754 equals y plus 110. But plus 110 needs to be canceled out so that y is isolated, so I'm going to subtract 110 from both sides. Y is left on the right, and when I subtract 110 from 754, I get 644. So Renee Montgomery has 644 points in the 2008 to 2009 season.